Alright, sorry for that brief interruption. Anyways, I forgot where I was, but I'm just gonna go with, okay, we're bringing moles of CS2 down, and we're gonna use our little coefficients, and so, in this case, we're going from moles of CS2, which is an understood 1, to moles of CO2, which is also an understood 1. Again, you can figure this out by looking at the coefficients. And so, this is just gonna be 1 to 1. So you have 1 mole of CO2. And the way we end our train tracks, because since this is what we were trying to get, moles of CO2, that we're pretty much done. So just end our train tracks by making 2 little lines, changing it up there. Whoa, whoa. Now we're going to multiply everything above this horizontal line here, and multiply everything on the bottom of it, and we're just going to write it off to the end. 1 times 1 is 1. Whoa. And then 1 times, well, I don't know, there's nothing else, so it's just 1, obviously. Okay. Now, for those of you math geniuses out there, 1 divided by 1 is, wait for it, 1! I'm gonna make it giant. Okay, 1 mole, because, you know, labels are always important, all the time. So, we have 1 mole of CO2 made with 1 mole of CS2. Now we're going to do that same exact thing with moles of oxygen. So we're going to create another pair of train tracks. I don't know, another set of train tracks with oxygen. Now in this one, they give you 1 mole of each, 1 mole of CS2 and 1 mole of O2. So we're going to start again with 1 mole of O2, since that's a given quantity that they give us, because it's given to us. Yay. Okay, so you have 1 mole of O2. Now this time we're going to, wow, I made that really big. Okay, so this time we're going to look at our coefficients for oxygen, and this time it is 3. So instead of looking like this one, okay, wait, first let's put moles of oxygen, because we want to go from moles of O2 to moles of CO2. Remember, we want to go to the same part of the equation that we went to in here, the same product that we went to in here. And, alright, so anyways, so now we're looking at our moles of O2, and since our coefficient is 3, we're going to have 3 moles of O2 for every 1 mole of CO2. Alright, so now we're going to do kind of like what we did in this one, and we're going to multiply everything on top. Well, it's 1 times 1 is 1, and then there's just 3 on the bottom, so we're just going to bring down 3. So it's going to be 1 over 3, and I'm going to kind of erase part of that because I made that way too big. Alright, so 1 over 3 is 0.3 repeating, or, you know, 3 going on forever and ever, moles of CO2. Alright. Now we have finished both of our train tracks. Now we need to figure out which is the limiting reagent. Well, let's think about this for a little bit. Limiting means that it kind of it limits the amount of products that are going to be able to be made. So, or that are, well, yeah, I guess, if that kind of made sense. I don't know, I just said I worded that very oddly. But anyways, the limiting reagent. So in this one, we can make 1 whole mole of CO2 using CS2. And using O2, you can make only 0.3 moles. So O2 is going to be our limiting reagent, considering you make less moles of CO2. Because if you're going to use 1 mole of O2 and 1 mole of CS2, the maximum amount you'd be able to make would be 0.3 moles, because I mean you'd run out of O2 by the time you made 0.3 moles, but you'd still have some excess left over. So right now we have determined our LR, or our limiting reagent. Here, I'm just going to give you a few more seconds to look at this, and then now I am going to delete all of that work that I just did, but no fear, I remembered. So we're going to put LR over O2, and this is our limiting reagent. And now we're going to put ER over CS2 just to remind us that that is our excess reagent. Alright, so now we've knocked out that first part. Okay, now, our second part of our little problem, how many moles of excess are left over? Alright, so we're still using all of this information from the top. We still have 1 mole of O2, and now that 1 single mole of O2 is what we're going to be using for that's going to be our starting point for all of our train tracks for the rest of this problem, because that's our limiting reagent. And that's just always how the way it is, because you're always going to start with your limiting reagent, just because, you know, that's just how it works out, you know. Because if you start with your excess reagent, then it's hard to just explain, but it makes sense when you think about it. So anyways, my brain just totally farted out on me. How many moles of excess? Okay, yeah, moles of excess reagent. Alright, so we're going to start with 1 mole of oxygen. So now we're going to bring moles of oxygen down. And now we're going to bring up moles of CS2. Alright, so then we're going to refer back to our coefficients, and this is again understood 1. And so for oxygen, it is going to be 3. And for CS2, it is going to be 1. Alright, now just a second. Alright, sorry for that little intermission. Okay, actually that was only like a few seconds to you guys, so anyways, where was I? Okay, so we're trying to find the moles of excess, and you have 1 mole, and you're, okay, yeah. So what you're trying to do now is, with this little thing, you're trying to find the moles of CS2, and so we are going to end up with 1 over 3, and the way this actual problem was written was like the 1 was 1.00, so that would give you 3 significant figures. So whenever I write this out, it's going to be 0.123, so 0.333. So, and those are going to be your moles of CS2 that were used. That's such wonderful handwriting. I know. Okay. Oh my god. It looks like a random squiggle. Okay, anyways. I don't even know. Okay, pretend that has 0.333 moles of CS2. Just pretend. Use your imagination. Okay, anyways. But wait. We're not done yet, because these aren't the moles of your excess left over. These are the ones that are used. Because you use up all of your 1 mole of oxygen, and then it's saying like how many moles of oxygen, or how many moles of CS2 are used up with 1 mole of oxygen, and you're going to use 0.333. I don't know why I sang. I guess I'm in a musical mood all of a sudden. But anyways, so you have 1 mole of CS2, right? And then this is how much you used. So to find out how much you have left over, you're just going to subtract 0.333 from 1. And that's going to give you 0.777. Pretend that those are all very beautiful 7s. And then those are your moles of CS2 left. I seriously didn't even mean to make that little thing. But anyways, left. And then I'm going to circle that, I'm going to star it, I'm going to make a little arrow to it, make a little smiley face, so that's important. That's a retarded smiley face. Okay, anyways. I don't know, I didn't even mean to do that. Okay, anyways. So that's how you find out how many moles of excess are left over. Now I'm going to let you glance at it, look at all the work, and delete. Alright. Now, for our last part of this little problem, how many moles of each product are formed? Alright, Now what we're going to do here, remember that when I said earlier that you're always going to start out with a quantity of your limiting reagent. So it's going to be 1 mole of O2. Now what we're going to do is we're going to find the moles for each product. Now we figured out the moles of CO2 in the beginning, and I do believe it was 0.333 moles. But we can go over that again really fast, because, okay, remember that you have 1 mole of O2, then you're going to go down to 3 moles of O2. And then we're going to go, what we're trying to find is moles of CO2. So you have moles of CO2, and you only have 1 mole of CO2. So then you put a little ending part, and then you multiply everything on top, and then you multiply everything on bottom, which is only one thing, so you don't really multiply anything, you just kind of write down the number. 1/3, 0.333. Alright, now that was pretty easy, right? But now we're going to go for SO2. Now, we're going to start out the same way. 1 mole of O2. I swear, the longer I spend using this mouse, the worse I get. See, look at that! Okay, anyways. Oh my gosh. Okay, anyways. We're going to bring down moles of O2, like we did up here. But instead of bringing up moles of CO2, we're going to bring up moles of SO2. Now you have 3 moles of O2. Now we're going to look at our moles of SO2. Oh, look at that. Our coefficient is a wonderful and glorious 2. So we have 2 moles of SO2. I feel like I'm going to... never mind. Okay. Okay, that was like a really tiny burp, and none of you guys heard that, which is awesome. Okay, now we're just going to multiply everything on top, and that's going to be 2 times 1 is... oh my gosh, it's 2! Oh! And then 2 over 3, I'm going to erase all that crap. Okay, 2 over 3, 2/3, 0.667. Okay, 0.667. Oh my gosh, what did I do here? I completely left off my moles. Okay, don't follow my example. Okay, this is CO2. I'm gonna write it up here. And then I wrote that by the CO2 so you can tell. It's CO2. Okay, anyways. And then this 0.667 moles of SO2. Okay, this isn't paint, so I can't just undo everything I just did. But ignore all of those little scribbles. Look at my work. Admire it. Admire it. Actually, wait, no, I can't undo all those little scribbles. Haha! Okay, now look at my work. Admire it. Look closer at it. Now, 0.667. I'm just gonna write that up here just for, I don't know. Why not? Why not? And then that's for SO2. And now you know how many moles of each product are formed, and now you should be able to do one of these equations. Awesome! Alright, thanks for watching my video, guys. Yeah, you guys have been a great crowd. Excellent crowd. Bravo, bravo, and bye.